Hello and welcome to the course on vector calculus. This is very important for people who are studying engineering or physics. So, if you're either from like electrical engineering or EC, electronics and communication, or mechanical, and many other branches like instrumentation or physics, if you are giving these gate papers, then understanding vector calculus is important for your core subjects as well as to score marks in mathematics. So what is a vector? A vector is something that has magnitude. You can also call this as length, and it has direction. So basically, if I draw this vector, so its length represents the magnitude, and its direction is defined with respect to some axis, conventionally or mostly with respect to positive x-axis. So now consider this vector as a bar. Now it has certain magnitude and direction. Now in the space, take another vector b bar. Let us consider another vector b bar. Now if b bar has same magnitude and the same direction as a vector, then a bar and b bar are both same vectors. Either you can put arrow or bar for vector, are both the same vectors. So it doesn't matter where you draw. If the length or magnitude and direction is same, then it represents the same vector no matter where you draw it. So we compute vectors by introducing coordinate system. So there could be n number of dimensions, but conventionally and mostly we use three dimensions for our case. So also we use a convention that is right hand convention. Like, so we have x axis here and y axis. So this is how it is. Imagine that you are rotating a screw from x to y, then it will move towards z axis. So this is the standard convention for when we represent or compute the vectors. For a vector a bar, um, example a1 I cap, a2 j cap, and a3 k cap. So here I cap, j cap, and k cap are unit vectors along the three coordinate axes. And a1, a2, a3 represents component along x-axis. Similarly, a2 is component along y-axis and a3 is component along z-axis that you may write. Now this vector, it can be this vector a bar, it can be represented like this: a1, a2, a3, in this fashion. So if it is given like this, then that implies that the vector a is this a1 I cap. You may uh, write from this notation. And so length or magnitude of the vector, length or, so I'm just going from the basics, but as we go along you will see the whole concept of vectors. So this is just the basics that we need to familiarize before understanding. So here a bar equal to under root a1 square plus a2 square plus a3 square. So this means that length is always positive. Length or magnitude of the of any vector is always positive. And for unit vector, the length or magnitude is 1. Also, this is the length or magnitude is scalar. Now to find the direction of the vector a bar, direction of this a vector is um, vector a by divided by its magnitude or length. So basically it turns out to be a1 I cap plus a2 j cap plus a3 k cap divided by a1 square plus a2 square plus a3 square. So this is the direction. So it's easy to find the length and direction of a vector when it is given in this fashion. So from coordinate space of 3 dimensions or n number of dimensions, how we can compute the length of the vector? Suppose if we have 2 points like this in the coordinate three-dimensional space, let me call that as P and Q. So we know that these 2 points have some coordinates. Uh, for example, let's take an example like 1 comma 3 comma 2, and here Q as something like you can take anything like 5 comma 1 comma 1. Let's say these are the 2 points. Now the vector pq, so vector pq will be, so here the first 5 represents the x coordinate. So when we are writing the vector pq bar, in that case, so here between p and q, q is the second point. So consider the q, and here x coordinate is 5 and then minus with 1. So it will be 5 minus 1 I cap. Similarly, the vector is pq, so start with the q point, that is 1 minus respective y coordinate 1 minus 3 j cap and 1 minus 2 k cap. So here we got the vector 4 I cap minus 2j cap minus k cap. So here the now I have to represent the vector. So as it is vector PQ, Q is coming second, so the arrow will be here. Now what is the length or magnitude of the vector PQ? It will be the distance between P and Q. So we know from Pythagoras theorem, if it is the Pythagorean theorem extrapolated to three dimensions, then in that case it will be um, like x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So which comes out to be 4 square 16 plus 2 square 4 plus 1. So like root 21. So that's how the length or magnitude of vector is defined. So here also if you do like a1 square, a2 square, a3 square as in the previous case 16 plus 4 plus 1. So which is root 21. Hence we calculate the length or magnitude, and direction we can calculate by dividing the vector PQ by root 21. So that's the direction of the vector. So the important thing to note here is we can consider vector in n dimension. For example, let me do for 5 dimensions. Sup, in the 5, we can represent the means most conventionally we use 3 dimensions, but it is applicable for n dimensions also. Like for example, if a point like m is having 5 coordinates like 1 comma 4 comma 3 1 comma 1, and suppose n having 0 comma 2 comma 1 comma 3 something. So now we can also make vector for this 5 coordinate system. We can also compute vector here. So here we have ijk 3 unit vectors along xyz. Additionally, for this we get two more unit vectors along those particular directions. So here it won't be the difference between coordinates won't be 90 degrees anymore. It will be different. However, we can consider any anyway. This is not that important for us, but just to keep in mind that the vectors can be computed in any dimension, but mostly we need in 3 dimensions. We deal with 3 dimensions mostly. Now let's turn our attention to something that is more important for um, many understanding and computing many concepts in our core subjects. That is vector addition. So most people do some mistakes in vector addition. Uh, okay, before going to vector addition, let's clear with some other concepts uh, that are important to understand the vector addition perfectly. Um, let's consider a vector a bar. Now we can multiply this vector with a scalar. Like let k is a some real number. Now when we multiply k with a bar, we get another vector ka bar. So by this multiplication doesn't change the direction, but it changes the magnitude. It changes the magnitude or length by k times. In fact, absolute value of k times. Suppose if we multiply with minus 3, then the magnitude of the vector a, a will change by 3 times. So it will become 3 times. Okay. Now the next concept is very important to in vector calculus. So vectors, there are two types of products when we are multiplying with vectors. One is vector multiplication. We have two kinds of vector multiplication. One is dot product and the other is the cross product. So in this lecture, let's understand the physical significance. What does it mean actually doing dot product or doing the cross product? What does it gives when we do cross product or dot product between the two vectors? Firstly, let's focus on dot product. So dot product, I will show you graphically. So we have, let's have two vectors like this. Okay. Now this vector is a bar and this vector is b bar, and there is an angle between them theta. So now we have to perform the dot product a bar dot b bar. So what does this imply? So this implies that, so it's with this what we are doing is we are multiplying magnitude of a along b direction, along b vector direction, times magnitude of b, magnitude or length of b. So anyway, we the magnitude of b, we know that it is we can calculate from the vector, that is magnitude or length of b. But now we have, our task is to calculate magnitude of a along b. I will represent that as this one. This is magnitude of, please you may write, it's somewhat tedious for me to write each and everything. So whenever I say, please do write that what does AB mean. AB means magnitude of A along the B vector direction. So this vector A along this direction. Now in order to find that, we have to draw a perpendicular like this. So here to here, such that this will be 90 degrees. So now this is how we will get along this direction how much it is. So here what represents AB, this one, This is represented. This represents AB. So how much is that we have to calculate? So cosine of theta is adjacent side by this A. So now here anyway this represents the length or magnitude of vector A. So cosine of theta is equal to adjacent side, that is AB. We may put like this, by hypotenuse, which is length or magnitude of vector A. Now this will give us AB, which is equal to magnitude of A cosine of theta or cos theta basically. Um, so basically cos theta is equal to this one. Now what is our dot product? Dot product is A bar dot B bar is equal to AB into magnitude of B, and but we know that magnitude of AB is cos theta into magnitude of B, which we can write as this way. So we calculated the dot product in this fashion. Now how about B dot A? Is B dot A same as A dot B? So if we do B dot A, then just once we have able to derive the formula, we can um, write it like this: magnitude of B, magnitude of A, cos theta. So we know that this equation 1 and this equation 2 are equal. 1 equal to 2. So A dot product of vector A and B equal to dot product of vector B and A. Anyway, this more than anything, how we are computing or calculating the dot product, that is important here. Um, next thing, next important concept is angle between two vectors. So for example, we have two vectors. A bar is equal to something like 3 I cap plus 2 j cap plus k cap, and vector B is 4 I cap plus j cap plus k cap. For example, these are the two vectors. Now what is the angle between vector A and vector B? So it's very easy now because by calculating the dot product. Now when we do dot product, we get mag. So this is the dot product, and we know how to multiply the two vectors A bar dot B bar. So we have to multiply 3 with 4. So why that means? So basically 3 I cap plus 2 j cap plus k cap multiply with 4 I cap plus j cap plus k cap. Now each term we have to multiply with other term. But when we multiply 3 with 4, 3 I cap with 4 I cap, since the angle between them is 0, here 3, 4 and cos 0 is 1, so that we will get 12. But when we multiply 3 with 3 I cap with j cap, the angle between I cap and j cap is 90, so the cos 90 will be 0, so that will be 0. And when we multiply 3 I cap with k cap, between I cap and k cap there is 90 degrees, so cos 90 will be 0, so that is also cancelled. So only uh, the same direction components will be multiplied have and has some as value. So here 2 multiplied with 1 we will get 2, and k multiplied with 1 k cap multiplied with 1 k cap will give 1. So this will be 15, and we know that dot product of a. Also we have another way to calculate dot product, that is length of um, this is cos theta. So we know the length of a. So basically, it is if it is given as simply vector a bar, that implies OA bar, where O is the origin. So this is 3ik. Yeah. Basically, it is the distance from the origin. So when the vector simply is given as a cap, that implies that it is OA cap, and the distance is given from the origin. So the magnitude of a is under root 3 square plus 2 square plus 1 square, which is 9 4 13 1 14 root 14. Similarly, magnitude of b, you may calculate here like 4 square 16 plus 1 plus 1, which is root 18 times cos theta. Now so these two are equal. 15 is equal to root 14 into root 18 cos theta. Theta is equal to cos inverse 15 by root 14 into root 18. You may calculate this, you will get the angle between the two vectors. So this is pretty easy, and it can be done very quickly. So just calculate the magnitude of A, B, and then do dot product. Then equate them and solve for angle theta. You will get that. Now let's focus on vector addition. See carefully how the vector addition is being done. Um, Suppose we have a vector A and we have a vector B. Now, if there is another vector like this, let me use another color. So, so now here C bar, how we are going to write, like this is tail and this is the head of the vector. Arrow is the head. Now when we start from here, we write A bar, and when we go, then we met with arrow instead of tail, like in this case of notation. So this will be minus C bar. Now And when we came here, again we met with arrow. So this is b bar, and totally it is 0 because we came to the same point. So we started with tail, so plus a bar. Then initially we met with the arrow first, so minus c bar. And for b bar also we met with arrow first, so that is minus b bar. Now here a bar minus b bar is equal to c bar. So now the vector c in this case, it is the subtraction of a bar minus b bar. So here we only use the language of vector addition. We may think like a bar plus of minus b bar equal to c bar. We can also call subtraction, but just as for as long as we deal uh, yeah, just for namesake vector addition. Now, so how to define the vector c bar? Now we have to find c bar, which is a bar minus b bar. Now what we will do is we will multiply. So this is consider 1. Just multiply 1. Sorry, do the dot product between 1 and 1. Not regular multiplication, but it's dot product. So in both sides, c bar dot c bar. The other side, a bar. No, yeah. Now we know that when we do dot product, on this side we get magnitude of c, and angle between c and c, which is 0. So cos 0 is 1. So leave it like that. Now with the a bar um, minus b bar and this, so when we do dot product between a and a, it will be magnitude of a into magnitude of a square. Now with a with b, in this case it will be magnitude of a, magnitude of b, and cos theta, where theta is the angle between the two vectors a and b. So basically this is the theta which I am writing here between a and b. And then the second term minus b times a, that is also same, that is cos theta, and minus b into minus b dot product with minus b, which is minus into minus plus, and magnitude of b whole square. So on this side, magnitude of c square, this is equal to magnitude of a square. I'm writing b as in the first, just as second term. So and minus a, and these two are same. So adding them will give us cos theta. So this is how we got the vector c magnitude. Basically, we get magnitude. So vector c magnitude we got, and now we also need to get vector c direction. Okay, so this is how we calculate the magnitude or length of vector C. Direction we will see in the future, but for now let's confine to finding the magnitude of the vector C bar for A bar minus B bar. Now let's consider the case how it will be A bar plus B bar in the same vector addition. Let me take two vectors. So vector A bar and vector B bar. So in the beginning we have seen that no matter where you write the vector, it will be same in case the magnitude and direction are same of that vector. So I can write vector A bar like this because its magnitude is same as this one and its direction is also same as this one as it is parallel to A bar. Now I am writing another vector. It has arrow. Draw properly that both arrows meet here of this C bar and now let's go in from tail here of the C bar. So C bar will be positive. Now when we come here, we meet with the A bar arrow, so that will be minus A bar. Now again the same with B bar, so minus B bar is equal to 0. When we take A and B other side, it will be is equal to C bar. Now for this case, you may compute what is magnitude of C. You may do by yourself, just like in the previous case, like is equal to. I will leave this to you. Okay, uh, let's move on. Let me take a 1 minute break. Not even 1 minute, but few seconds. Okay, now let's check this out. Suppose if we are given two vectors, A bar and vector B bar. Now we have to check whether A bar and B bar are perpendicular or not. To check, so in order to do that, what we have to do, we have to do the dot product, like a bar dot. Now, if the dot product leads to 0, that means that cos, the angle between the two vectors is 90, and cos, because of cos 90, it is 0. Hence, this is perpendicular. Two vectors are perpendicular. Now, if this is not equal to 0, then not perpendicular. Okay, now let's look at a plane perpendicular to the vector. A plane perpendicular to a given vector. So let us consider a vector a bar is given, like for example 3 I cap plus 2j cap plus k cap. This is the vector given. Now we have to find the plane, equation of the plane that is perpendicular to a bar. Perpendicular to vector a bar. Now in order to do that, um, so if if a plane, for example, like this, so this is the vector a bar, imagine it as straight, so this is perpendicular. Now suppose let's take a point here, some arbitrary point. Now we know that this is 3 2 1. So as I told earlier, a bar means OA bar taken from origin to the point A. This is the point A, 3 2 1. So basically this is origin, you can say, you can think of it as origin. This point is O, on which is on. Now let's take another arbitrary point P, which is X Y Z. I don't know the coordinates of that point, but it is X, Y, and Z. So what is the vector P? That is xi cap plus yj cap plus z k cap. Now, so what is the P vector is in this fashion. P vector is this one here. This is P. So This is p vector, and you can see here that a and p are perpendicular to each other. So dot product of this should be 0, and this is equal to we can multiply like x with 3, that is 3x, y with 2, that is 2y, plus z with 1 is z. So 3 so 3x plus 2y plus z equal to 0. So this is the equation of the plane. Y means any point, any arbitrary point on this plane that satisfies this equation. Uh, so any point on this plane will satisfy this equation, like any xyz on this plane. So whatever the point you consider on this plane, and that vector will be perpendicular to um, vector a bar. Imagine a ground. So a ground is a plane, and suppose imagine a pole like of a badminton pole, iron pole, that is perpendicular to the ground surface. Now take a stick and place on the ground. No matter in which direction you place on the ground, uh, it will be perpendicular to that iron pole. So here A bar is that iron pole of the badminton, and um, whatever whatever the stick that you are putting on the ground, it is placed on the plane. So suppose if you consider that the pole is placed at the origin. Now, from origin to, or even on the ground, wherever you put that stick, it will be perpendicular to A bar. So, that will be one particular plane. And that equation of that plane um, we can get by assuming an arbitrary point xyz and then multiplying and equating to 0, so that that will be the equation of the plane. Now let's um, focus on some interesting things that we can do with vectors. As from the beginning, we have seen that a vector represents magnitude and direction. So consider a vector like this, two vectors in fact. So this is vector A and this is vector B. Now I'm joining this. So this is theta. Let me not let me write in a more arbitrary manner, not this. So this is vector A bar and vector B bar. So I'm just joining these two ends. Now I have with me two vectors A and B. Can I find the area of this triangle? Area of triangle. So in order to do that, one thing we can do is just take a perpendicular like this. Here we have 90 degrees. Now we have here the triangle. So triangle has the base. This is the base of triangle, and we can see that it is the vector b. So magnitude b is the base, and this is the height of the triangle h. We know that area of triangle is equal to of bh. So we from the two given vectors a and b, we can easily calculate magnitude of b. But now next is that we have to calculate h, so this height. Now also we know the angle between two vectors. We can compute and find, as we have seen previously, how to calculate. Now um, sine of theta is equal to height h by hypotenuse is length or magnitude of vector a. So here h is equal to sine theta. So how we will get sine theta? First calculate cos theta, as we have seen previously. Do dot product of a bar and b bar, and then do this sine square theta plus cos square theta is equal to 1, and then find sine theta. So you get h from this. Now what is the area of triangle? Area of triangle would be, let me use blue. Um, this would be half times base is uh, magnitude of b, and h is magnitude of a sine theta. Just rearranging in upper, we get sine theta like this. Next lecture we will see more um, advancing on these concepts. So just introduced to you here how to calculate area, but this is just somewhat geometrical in nature, and uh, just it is introducing us to see what we can do with vectors to calculate areas and volumes and so on. But this is just a crude form of calculating. I would say this is just a crude form of calculating, because the triangle formed with this we have seen, um, we have calculated sine, in fact cos theta, then calculated sine theta, then substituted in this formula, and we got area. So this is having more steps, and it is more l- lengthy in computation, but rather we will see how to compute in less number of steps and what that would be. So that would be cross product. So in the next lecture, let's start with the cross product and see other concepts along the way. Thank you so much for watching, and please subscribe this channel to get more concepts of mathematics. Thank you.